Jai Hind to all. Today we start a new chapter, Applications of Derivative. CBS deleted two sections from this chapter, Rate of Change and Approximation. Also, this chapter included three sections, Tangents and Normals, Increasing, Decreasing and Maxima and Minima. In these three sections included 1, 2, 3 and 5 mark questions also. So, this chapter is a very important chapter and try to practice it for getting a good marks. Now we start the class. Now we discuss a new chapter, Applications of Derivative. In this section, already two portions are deleted, Rate of Change and Approximation. The remaining three sections are very important for this chapter. First is Tangents and Normals. Second is Increasing and Decreasing Function and Maxima, Minima. Today we start our first section, Tangents and Normals. Before starting the chapter, first of all we remind some portions from the first year classes. First is, you already know a line which makes an angle theta with the positive x-axis, then slope m is equal to tan theta. Suppose a line passing through two fixed points, our first point is x1 y1, second point is x2 y2, then the slope of this line, slope m is equal to for the y2 minus y1 divided by x2 minus x1. A line pass through a fixed point x1 y1 and having slope m is given, then the equation of that line is y minus y1 is equal to m into x minus x1. If two lines are parallel, their slopes are m1 and m2, then the condition for parallelism is m1 is equal to m2. And if two lines are mutually perpendicular, suppose the first line slope is m1 and second line slope is m2, they makes an angle 90 degree, then the condition for perpendicularity is m1 into m2 is equal to minus 1. These are the main points on first year classes we discuss in our first year classes. It's very important for tangents and normals also. Okay. Already two methods, slope and two methods already first year. The first is a line which makes an angle theta with a positive x-axis, then slope is tan theta. A line passing through two fixed points, then the slope is y2 minus y1 divided by x2 minus x1. And a line passing through a fixed point and slope m is given, then the equation is y minus y1 equal to m into x minus x1. If two lines are parallel, their slopes are m1 and m2, then the condition for parallelism is m1 is equal to m2, and condition for perpendicularity is m1 into m2 is equal to minus 1. Now come to our main topic, tangents and normals. Okay, tangents and normals. Tangents and normals. Actually, it's a simple portion, but this portion contains some special problems that's very important. Here we first of all we consider a function. Suppose y is equal to f of x. Here the geometrical interpretation of this function y is equal to f of x is drawn. There contain infinite number of points on the curve. Y is equal to f of x is geometrically interpreted. We get a curve. Suppose y is equal to f of x. This curve contains infinite number of points. From these points, we form a line passing through a fixed point. Suppose x1, y1, that point is x1, y1. If a curve touch a particular point, line, that line is called tangent line. A line passing through a fixed point to the curve y is equal to f of x is called a tangent line. and a line which is perpendicular to this tangent line pass through this same point x1 y1 is called normal line. This line is called a normal line and this line is called a tangent line. Here we want to find the equation of this tangent line and a normal line using derivative. In this topic we want to find the equation of this tangent line and normal line using derivative. You already know how to find the slope of a line using two methods. The angle of inclination is given, then the slope is tan theta, and a line passed through two fixed points is given, the slope is y2 minus y1 by x2 minus x1. Now we discuss a third method for finding the slope of a line. So suppose a curve is passing through, line is passing through a fixed point. Then using this curve, we find the slope of this tangent using derivative. First of all, we find the derivative of this function, that is y is equal to fx. You know the derivative. Slope is equal to derivative is dy by dx. Then passing through that touching point x1 y1, we get slope of this line. This is the third method for finding the slope of a line. But the line in the slope is the third method. Curve touch line pass that line in the slope, that line is called a tangent line. A tangent line the slope curve differentiate the touching point pass here. This slope and these three slopes are equal, same. Suppose the line positive x axis to make the angle theta, and then the slope is also equal tan theta. Also same line pass through another point, suppose x2 y2, using the formula y2 minus y1 by x2 minus, and we get the same slope. So which is the third method. For finding this slope, we want curve also. For curve method slope curve touch line pass that line is called a tangent line. The tangent line slope we use this method, that is curve differentiate the touching point pass here, we get slope. Now we find the equation of this line. Now the equation of the tangent line. Now you find the equation of the tangent line. This line passing through the point is x1 y1 and the slope of this line is dy by dx at x1 y1. And using this formula y minus y1 equals slope into x minus x1 formula. Using that formula we get answer. Equation of tangent is y minus y1 is equal to, here slope corresponding term is dy by dx at x1 y1 into x minus x1, which is the equation of a tangent line. And slope of this tangent line is dy by dx at x1 y1. Now we find the equation of this normal line. You know these two lines are mutually perpendicular, and therefore you know when these two lines are perpendicular, then slope or product of the slope is minus 1. Suppose this line slope is m1 and this line slope is m2. Then slope of one line is given, then the slope of the second line is negative reciprocal, because m1 into m2 is equal to minus 1, and therefore suppose first line slope is given, then the second line slope is negative reciprocal of the first line slope. That is slope of the normal. Slope of the normal. Slope of the normal is equal to, slope of the normal is negative reciprocal of the slope of the tangent. Here the slope of the tangent is, we get answer dy by dx at x1 y1. Then the slope of the normal is equal to negative reciprocal means minus 1 divided by dy by dx at x1 y1. This line is also passing through the same point x1 y1, and now we find the slope, we get slope is minus 1 by dy by dx at x1 y1. Therefore the equation of the normal line is y minus y1 is equal to minus 1 divided by dy by dx at x1 y1 into x minus x1, which is the equation of the normal line. These two lines are the main equation of tangent and normal line. Okay, this is a very important section. Equation of tangent and equation of normal. It's the equation of tangent and it is the equation of normal. Here the slope of the tangent is dy by dx at x1 y1, and slope of the normal is minus 1 by dy by dx at x1 y1. Okay, now we start the problems using this formula. The first question is find the slope of the tangent to the curve Find the slope of the tangent to the curve y is equal to 3x raised to 4 minus 4x at x is equal to 4. Find the slope of the tangent to the curve y is equal to 3x raised to 4 minus 4x at x is equal to 4. You already know slope of the tangent formula is dy by dx at x1 y1. First of all, we find the derivative of this function dy by dx. That is 3 into x raised to 4 derivative is 4x cube minus 4 into derivative x with respect to x is 1. That is equal to 12x cube minus 4. Is only derivative. Now we find the slope of the tangent using the formula dy by dx at x1 y1. Actually, this function is an explicit function of x. So, okay, x1 y1 in the only we get x, that is x is equal to 4 is already given. That is equal to 12 into 4 cube minus 4. That is equal to 12 into 4 cube is 64 minus 4 is equal to answer 768 minus 4. We get answer 764. That is the slope of the tangent to the curve y is equal to 3x raised to 4 minus 4x at x is equal to 4. Now the second question. Find the slope of the tangent and normal to the curve y is equal to x cube minus x plus 1 at x is equal to 2. At x is equal to 2. Question is, find the slope of the tangent and normal to the curve y equal to x cube minus x plus 1 at x is equal to 2. Here, first of all, we find dy by dx. You know the derivative x cube is 3x square and minus x derivative is 1 and 1 derivative is 0. And therefore, slope of the tangent is dy by dx at x1 y1. Here x is equal to 2. Function is an explicit function. So 3 into 2 square is 4 minus 1 is equal to answer is 11. That is slope of the tangent. Also the second question is slope of the normal. Slope of the normal means negative reciprocal of the slope of the tangent, that is minus 1 divided by 11. That's all. That is a slope of the tangent and slope of the normal. Now discuss one more question for finding slope of the tangent. Our third question, find the slope of the tangent to the curve x is equal to a cos cube theta, y is equal to a sin cube theta at theta is equal to pi by 4. Actually, this function is an implicit function. It's a parametric function. Actually, this function is a parametric with a parameter theta. So, first of all, you know dy by dx formula. Dy by dx is the slope of the tangent. So, before finding dy by dx, you know the formula dy by d theta divided by dx by d theta. That is, first we find the derivative of x with respect to theta. A into cos cube derivative, which is of the form s cube. S cube derivative is 3 cos square theta into derivative cos theta is minus sin theta, function. Then dy by d theta is equal to a into sin cube derivative s cube form, that is 3 sin square theta into derivative sin theta is cos theta, and therefore dy by dx is equal to dy by d theta divided by dx by d theta. In a parameter derivative, you know formula dy by dx is equal to dy by d theta by dx by d theta. You know what is dy by d theta? 3a sin square theta into cos theta the whole divided by minus 3a cos square theta into sin theta. Here 3a cancel, sin cancel, cos cancel, and therefore we get answer minus tan theta. Now we find the slope of the tangent. Slope of the tangent means dy by dx at theta is equal to pi by 4, and last we put theta equal to pi by 4, and therefore we get answer minus tan pi by 4 is equal to answer is minus 1. Suppose we find the slope of the normal, we find the negative reciprocal of the slope of the tangent, we get answer 1. That's all. That is the slope of the tangent and normal to the curves. Now we discuss some problems, equations, to find the equation of tangents and normals. First question is find the equation of tangent and normal to the curve y is equal to s cube. Find the equation of tangent and normal to the curve y is equal to s cube at 1, 1. Equation of tangent and normal to the curve y equal to s cube at 1, 1. Here x1, y1 is already given, that is 1, 1. Before finding the equation, first of all we find the slope of the tangent. That is, first we find dy by dx. You know the derivative of s cube is 3x square. Therefore, slope of the tangent is dy by dx at 1, 1 is equal to 3 into 1 square. Now we form the equation of tangent. You know the formula is y minus y1 is equal to slope of the tangent is dy by dx at x1 y1 into x minus x1. Here x1 y1 correspond to value is 1, 1, that is y minus 1 is equal to 3 into x minus 1. Actually the tangent line is a straight line, so we simplify the given equation, convert in the form ax plus by plus c equal to 0 form. You know the equation of a line in our last year we discussed general equation of a line is ax plus by plus c equal to 0. So we simplify the ax plus by plus c equal to 0 form convert here. That is y minus 1 is equal to 3x minus 3. That is minus 3x plus y is equal to minus 3 plus 1, that is minus 2. That is the equation of tangent. Now we find the equation of normal. Equation of normal, you know formula is y minus y1 is equal to negative reciprocal. നമുക്ക് separate slope of the normal കണ്ടുപിടിക്കേണ്ട formula direct substitute ചെയ്താൽ മതിയാവും. Negative reciprocal, that is minus 1 by dy by dx at x1 y1 into x minus x1. Separate slope of the normal നിങ്ങൾ കണ്ടുപിടിച്ച് substitute ചെയ്ത് കഴിഞ്ഞാൽ ഒരു confusion make ചെയ്യും. So we find only slope of the tangent. ആ slope of the tangent substitute ചെയ്ത് equation of normal form ചെയ്യാം. That is y minus 1 is equal to minus 1 divided by, you know dy by dx at x and y1 is 3 into x minus 1. On cross multiplying 3 we get answer 3 into y minus 1 is equal to minus x plus 1. That is 3y minus 3 is equal to minus x plus 1. And therefore x plus 3y is equal to minus 3 raised to minus 3 plus 1, answer is 4. We get the equation of normal. That's all. It's a very simple question, it's a direct question. Okay. Okay, I will discuss one more question similar to this type. Find the equation of tangent to the curve y is equal to x raised to 4 minus 6x cube plus 13x square minus 10x plus 5 at 0, 5. Actually 0, 5 which satisfies the given equation. When you put x equal to 0, y is equal to b times 5, that is x and y1. Okay, here given the given point x1 and y1 is 0, 5. For find the slope of the tangent, first of all we find the derivative of this function. X raised to 4 derivative is 4s cube minus 6 into s cube derivative is 3x square plus 13 into s square derivative is 2x minus 10 plus 0. And therefore slope of the tangent is dy by dx at x0, 5. When we put x equal to 0, these types are vanishes and we get answer minus 10. And therefore slope of the tangent is, answer is slope of the tangent is equal to, we get answer minus 10. Now the equation of tangent, you know the formula is y minus y1 is equal to dy by dx at x1 y1 into x minus x1. Here x and y1 is 0, 5 and therefore y minus 5 is equal to slope of the tangent is minus 10 into x minus 0. That is y minus 5 is equal to minus 10x minus 0. That is 10x plus y is equal to plus 5. That's the equation of tangent. That's all. Okay. Now we discuss one more question using parametric derivative. Find the equation of tangent to the curve x is equal to cos theta, and y is equal to sin theta at theta is equal to pi by 4. First of all, we find x and y1. Here x1 mean we put theta is equal to pi by 2 to x, therefore we get answer cos pi by 4. You know cos 45 is 1 by root 2. Then y1 means sin pi by 4, sin 45 is again we get answer 1 by root 2. And therefore x1 comma y1 is equal to 1 by root 2 comma 1 by root 2. X and y1 is set in. Now we find slope of the tangent. Before finding dy by dx, first of all we find dx by d theta. You know the derivative cos theta is minus sin theta. Dy by d theta, sin theta derivative is cos theta, and therefore dy by dx is equal to dy by d theta divided by dx by d theta is equal to cos theta divided by minus sin theta equal to minus cot theta. That is not a slope of the tangent, it's only a derivative dy by dx. Now we find slope of the tangent. Slope of the tangent for like dy by dx at theta is equal to pi by 4. We x and y substitute in the our function is in the parameter theta. So dy by dx at theta is equal to pi by 4. Answer is minus cot pi by 4. You know the tan pi by 4 is 1 and its reciprocal is also 1. That is minus 1. We get answer minus 1. That is slope of the tangent. Now the equation of tangent. That is y minus y1 is equal to dy by dx at x1 y1 into x minus x1. Here y1 corresponding value is 1 by root 2. Dy by dx at x and y1 is minus 1 into x minus 1 by root 2. That is y minus 1 by root 2 is equal to minus x plus 1 by root 2. Minus x left side we get answer x plus y is equal to 1 by root 2 plus 1 by root 2, that is 2 by root 2 is equal to root 2 because 2 is root 2 the whole square. That is finally we get answer x plus y is equal to root 2, which is the equation of tangent. These are some direct problems using the formula. Now we will discuss some special problems regarding the topic tangents and normal. This is also a very important section. Tangents and normal based, they are two important section special problems. NCERT based 6 or special problems are there. I will now discuss some special cases. It's a very important case. Special cases. Our first special case, that is SC1. Find the points on the curve y is equal to s cube at which slope of the tangent is equal to the y coordinate of the point. Find the points on the curve y is equal to s cube. If you have any doubts in the question, then we refer exercise 6.3, question number 17. Exercise 6.3, question number 17. If you have any doubt in the question, please refer this question. Our question is, find the points on the curve y is equal to s cube at which slope of the tangent is equal to the y coordinate of the point. That means here y is equal to s cube is a curve. ആ കർവിൽ ഇൻഫിനിറ്റ് നമ്പർ ഓഫ് പോയിന്റ് കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ട്. ഒരു പർട്ടിക്കുലർ പോയിന്റ് വഴി നമ്മൾ ഒരു ടാൻജന്റ് ലൈൻ ഇങ്ങനെ പ്രൊഡ്യൂസ് ചെയ്യുന്നു. Suppose that touching point is, suppose you take x1, y1. We find that point x1, y1. Only y is equal to equation of the curve is already given. How to find x1, y1? For finding the points, there they given a condition that slope of the tangent is equal to the y coordinate of the point. That means the y coordinate of the point means y1. First of all, given the curve is y is equal to s cube. First we find the slope of the tangent. Before finding the slope, dy by dx is equal to 3x square. Now the required point, you don't know what is the point x and y. So suppose the point is equal to x1, y1. നമുക്ക് ഈ എക്സ് എന്നാണ് കണ്ടുപിടിക്കേണ്ടത്. ഹിയർ ഡി വൈ ഡി സെറ്റായി. നൗ വി വിൽ ഫൈൻഡ് ദ സ്ലോപ്പ് ഓഫ് ദി ടാൻജൻറ്റ് ഈസ് ഡി വൈ ബൈ ഡി എക്സ് അറ്റ് x1 y1 is equal to, we get answer 3x1 square, which is slope of this tangent to this curve. Now we apply the given condition. Here given slope of this tangent is equal to y coordinate. Slope of the tangent means 3x1 square is equal to y coordinate means y1. 3x1 square equal to y1, or y1 is equal to 3x1 square. You know, x1 y1 is a point on the curve. So x1 y1 is automatically satisfy the given curve. And if when x1 y1 passing through this curve, we get answer y1 is equal to x1 cube. Now we substitute y1 equal x1 cube to the given condition. We substitute x1 cube to the y1. That is, what is y1? x1 cube. That is, x1 cube is equal to 3x1 square. That is, x1 cube minus 3x1 square is equal to 0. Cancel the solution. Now we take x1 square as a common term. Balance x1 minus 3 is equal to 0. And by using zero factorization theorem, either first term, that is x1 square equal to 0, or x1 minus 3 is equal to 0. When x1 square equal to 0, therefore x1 is equal to, we get answer 0. When x1 minus 3 equal to 0, we get answer x1 is equal to 3. Therefore the ordered pair x1 is already hit. Now we find the y coordinate. For finding y coordinate, we substitute x1 to the given curve. You know, x1 y1 satisfy the given curve, and therefore y1 is equal to x1 cube. When x1 is equal to 0, that implies y1 is equal to 0 cube. And when x1 is equal to 3, that implies y1 is equal to 3 cube 27. Therefore we get our required point. Therefore the required points are 0, 0 and 327. ഇപ്പോൾ ഈ രണ്ട് പോയിന്റ് വഴിയും കടന്നു പോകുന്ന ടാൻജന്റ് ലൈൻ അതിൻ്റെ സ്ലോപ്പ് അതിൻ്റെ y കോർഡിനേറ്റിന് ഈക്വൽ ആയിരിക്കും. Okay, it's a very simple portion, but it's a special problem. That is, our function is already given. We want to find the point. Tangent കർവിനെ ടച്ച് ചെയ്ത് കൊണ്ടുവന്ന പോയിന്റ് കണ്ടുപിടിക്കേണ്ടത്. We find x1 y1. You don't know what is x1 y1. Suppose that point is, you take x1 y1. First of all, we find slope, because the given condition is slope of the tangent is equal to the y coordinate. So finding slope of the tangent, first we find derivative, then we substitute x1 y1 to the derivative, we get answer 3x1 square. That is the slope of this tangent line. Now we apply the given condition. What is given? Slope of the tangent is equal to the y coordinate. That is, y coordinate is y1. That is 3x1 square equal to y1, or y1 equal to 3x1 square. Here x1 y1 is a point which is common to this tangent and the curve also. So curve x1 y1 satisfy, we get y1 equal to x1 cube. Now y1 equal to x1 cube substitute x1 cube equal to 3x1 square. And therefore x1 cube minus 3x1 square is 0. Here x1 square is common, we get answer x1 square into x1 minus 3 equal to 0. Then by using zero factorization theorem, we get answer x1 equal to 0, or x1 is equal to 3. When x1 equal to 0, y1 is also 0, and x1 equal to 3, y1 is equal to 27. 7. That's all. Okay, now we discuss one more special problem, SC2. Okay, SC2. Question is, find the points on the curve. Find the points on the curve y equal to x minus 2 the whole square, y is equal to x minus 2 the whole square, at which the tangent is parallel to the chord joining 2, 0 and 4, 4. The tangent is parallel to the chord joining 2, 0 and 4, 4. Same exercise, 6.3 exercise question number 8. Question number 8. If you have any doubt in the question, please refer 6.3 exercise question number 8. Find a point on the curve y equal to x minus 2 the whole square, at which slope of the tangent is parallel to the chord joining 2, 0 and 4, 4. Suppose the curve is y is equal to x minus 2 the whole square. A curve touch ചെയ്തുകൊണ്ട് ഒരു ടാൻജന്റ് ലൈൻ ഇങ്ങനെ പ്രൊഡ്യൂസ് ചെയ്ത് പോകുന്നു. ടാൻജന്റ് ലൈൻ പ്രൊഡ്യൂസ് ചെയ്ത് പോവുക. Suppose that line is a tangent line. Also, ഇതിനൊക്കെ പാരലൽ ആയിട്ട് ഒരു കോഡ് പോകുന്നുണ്ട്. That chord passing through the points is 2, 0 and 4, 4. കണ്ടെത്തേണ്ട കർവിനെ ടച്ച് ചെയ്യേണ്ടി പോകുന്ന ടച്ചിങ് പോയിൻ്റാണ് കണ്ടുപിടിക്കേണ്ടത്. ദാറ്റ് ടച്ചിങ് പോയിൻ്റ് യു ഡോണ്ട് നോ വാട്ട് ഈസ് ദാറ്റ് പോയിൻ്റ്. സപ്പോസ് വി ടേക്ക് സപ്പോസ് ദാറ്റ് പോയിൻ്റ് ഈസ് the required point is you take x1 comma y1. First of all, we find the slope of this tangent. Before finding the slope of the tangent, first we find the derivative of this function dy by dt is equal to 2 into x minus 2 raised to 2 minus 1 into x minus derivative is 1. Now the slope is dy by dx at x1 y1. Here x1 y1 is unknown and therefore 2 into we get answer x1 minus 2, which is the slope of this tangent. Here given this tangent is parallel to this chord passing through 2 points. Chord is a line. So we find the slope of this chord. Slope of the chord is equal to, using formula, y2 minus y1 divided by x2 minus x1 is equal to, here y2 is 4 minus 0 divided by 4 minus 2 is equal to 4 by 2, answer is 2, which is the slope of this chord. Here this tangent line and this chord are parallel and therefore their slopes are equal. That is, here 2 into x1 minus 2 is equal to 2 and therefore x1 minus 2 is equal to 2 by 2, answer is 1. x1 is equal to 1 plus 2, answer is 3. Therefore this coordinate is 3. For finding y coordinate, you already know x1 y1 is a point which is common to this tangent curve also. Now x1 y1 pass through this curve, we get answer y1 is equal to x1 minus 2 the whole square. When x1 is equal to 3, we get answer y1 is equal to 3 minus 2 the whole square, that is equal to 1 square, answer is 1. Therefore the required point is x1 y1 is equal to, we get answer 3 comma 1. That's all. Okay, so here a curve passing through a tangent line, we want to find the point on this curve. For finding this point, here already given a condition that this tangent is parallel to the chord joining 2, 0 and 4, 4. നമുക്ക് ഈ x എന്ന പോയിന്റ് കണ്ടെത്താൻ വേണ്ടി ടാൻജന്റ് ലൈൻ കോഡിന് പാരലൽ എന്ന് പറഞ്ഞിട്ടുണ്ട്. So first of all, you take the point, unknown point is take x1 y1. Then we find slope of this tangent using this curve. Curve differentiate x1 y1 pass here, we get the slope of this tangent. Now we find the slope of this chord, because the chord is a line passing through 2 fixed points, therefore the slope of the chord is 2, using formula y2 minus y1 by x2 minus x1. Here these two lines are parallel and their slopes are equal, that is 2 into x1 minus 2 is equal to, and therefore we get answer x1 equal to 3. Here x1 y1 is a point which is satisfy the given curve and therefore y1 equal to x1 minus 2 the whole square. Now we put x1 equal to 3 to the given curve and therefore y equal to, we get answer y1 equal to 1. Therefore the required point x1 y1 is equal to, answer is 3, 1. That's all. Now we discuss 4 more special problems on the next video. That's all today's class.